Hi, hello, and welcome to Math at a Go. Here we are on the fourth day of our 18-day action plan with the most interesting topic of 10th class. It involves the most interesting and our daily life questions like there is a garden in which there are some flowers and there are some bees flying over. If one bee sits for each flower, then one bee is left without a flower. And if two bees sit for each flower, then one flower is left without a bee. Then just tell me how many bees are there and how many flowers are there. So much interesting. Like that, there are so many very much interesting questions like age related problems, distance and time formula. So many interesting questions are there. This really helps a lot. This not only helps you with this 10th class but also in any competitive examinations that you'll write in your future examinations. So please concentrate on this. And this really builds up good mathematics language when you learn this chapter. So let us get into the chapter. The first question says write the standard form of a linear equation in two variables along with conditions. So let us see what he is asking. He is asking the standard form. What is a standard form first of all? Standard form is something which consists of all special characteristic features. That means every feature is seen in that. It is typical. So it possesses every character. Sometimes some of them may miss, but if you have the maximum of things, they are all possessed in this standard form. That is called a standard form. So let us see, this is a standard form of what? A linear equation. Linear equation in the sense its degree should be 1. And how many variables? In two variables. So let the variables be x sin y. You can also take any other variable. Now for the standard thing we are taking x sin y. So let this x sin y be two variables, and because the degree is 1, it should have minimum, one should have the power 1. Of course the other may also have the power 1. That's it. And he says it is an equation, so there should be an equality symbol. So there should be one x, there should be one y, and there should be an equality symbol. So where to place this symbol? Here or somewhere or what? And what are the chances of powers? Let us see. If the degree of an equation is 1, there can be terms with degree 1 or less than degree 1, that is of degree 0. So these two are the terms of first degree. So there can also be another term with 1 degree or less than 1 degree. For example, let us imagine if it is 1 degree, there should be some other variable. In that case, it becomes 3 variables. But here he is asking only about 2 variables. So let us not take z. So there will not be any more variables. Then what? The variable has got power 1, therefore the degree 1. And there is a chance for another term for it to exist in this equation with 0 degree. What can have a 0 degree? Simple, a constant. So along with these, a constant can also be there because its degree is 0. So its degree is 0, its degree is 1, its degree is 1, the highest of them is 1. Therefore this is called a linear equation in two variables. So you see, there should be one term with one variable x, another term with one variable y, another constant, and an equality symbol. All of these must be included to construct a linear equation. Now where can this equal symbol be? Here or here or here itself? Let us see. It can be anywhere, but because we are studying about a typical thing, we are making a plus symbol in between them, taking a plus symbol between all of them and equate it to some 0, because this also has 0 degree. So now this is an equation in two variables, a linear equation in two variables. So this is an equation in two variables. But what about the coefficient of x? Should it always be 1 or can it be any other number? Definitely it can be any other number. So let a be the coefficient of x and b be the coefficient of y. Then do we have a coefficient for c? No, it itself is a number, so it cannot have a coefficient, because coefficient exists only for a variable. It is not a variable, so it cannot have a coefficient. So ax plus by plus c is equal to 0 is the standard form of a linear equation in two variables. Done. Now what else? Have we finished answering the question? The question is write the standard form of the linear equation in two variables. Yes, we have written the standard form and yes, added a tail along with conditions about the conditions to be followed by the standard equation of this linear equation in two variables. Let us see what can be the conditions. X and y, there are no conditions because they have to exist. So we have nothing to do with x and y. But this x vanishes if this vanishes. Yes or no? If a is 0, x vanishes because 0 into x becomes 0. In that case, it becomes like 0 plus by plus c is equal to 0. In this case, we can consider it is not at all there. Now, can we say it to be an equation in two variables? No, it is an equation in one variable only. But because this is a special case, that maybe there is 0 as coefficient, so it may be possible. You cannot say it is impossible, it may be possible. For example, if b is also 0, what happens? 0 into y plus c is equal to 0. In that case, this all becomes 0. Then c is equal to 0, it becomes. But c is some constant, we said. How can one constant be equal to 0? So it becomes quite rubbish to say. That means you said when this becomes 0, okay, this will take care of the equation and it is valid, you said. But when this becomes 0, this is leading to something rubbish. Yes or no? So that means one can become 0, either this one or this one, but both of them cannot become 0 simultaneously. In that case, what happens? Both these variables disappear and it leads to an irrational concept of every constant being equal to 0. This is wrong. So we should take care to see that both of them should not become 0. Only one can become 0. Either a must be equal to 0 or b must be equal to 0, but both must not be equal to 0. This is very, very important concept. But how do we specify this? Both being not equal to 0, how do we specify that? We can't every time say either that should be 0 or this should be 0, but both cannot be 0. You cannot speak of this every time. Moreover, you should express it in mathematical terms. Then how can we do that? We can do it by saying a square plus b square must not be equal to 0. This implies that any one can be 0 but both cannot be 0. How? Let us see. So as discussed, a and b are any real numbers. A and b are any real numbers. Real numbers in the sense it can be a fraction, a decimal, a negative number, a positive number, or a 0. So both cannot be 0. So one can be 0. So if this is 0 and 0 square becomes like this, so it says b square something is not equal to 0. If you apply square root, b must not be equal to 0. So if a is 0, b must not be 0. It is the meaning of that. And if b is 0, a must not be equal to 0, it says. If both are 0, what happens? Let us see. 0 square plus 0 square. So 0 square means 0 square is equal to 0. So 0 is equal to 0. But it should not be, he says. But they have become already equal. So that means they both should not become 0. One can become 0, but both should not become 0. That is the meaning of that. And why he has taken squares? He could simply say a plus b is not equal to 0. Yes or no? Yes. It could be explained like this. Let a be any real number. If you square it, definitely it will be some positive number. Yes or no? And let b be any real number. If you square it, it will be definitely some positive number q. And if you add any two positive numbers, it will never result in 0. Yes or no? It could result in 0 when both are zeros. When both are zeros, it could result in 0. So that is why he is asking this should not be equal to 0. That means either this must not be equal to 0 or this must not be equal to 0. So instead of saying such a word, lengthy sentence in English, we simply use this one, a square plus b square is not equal to 0. So this is the condition that should be fulfilled. So this is the standard form of a linear equation wherein a, b, c are real numbers and a square plus b square is not equal to 0, which means both should not be equal to 0. Either a or b be equal to 0. And why should you write square only? You could simply write it like this, no? A plus b must not be equal to 0. Yes or no? In that case, let us see what happens. So it says a must not be equal to minus b. That means what? A and b should not be equal when you change its symbol. That means what? Simple. If it is 2 and b be any number, take any number and change its symbol, they will never be equal. What is this? It's rubbish. What is there the meaning in it? It appears really rubbish. So this can't really give you the proper explanation for the fact both should not be equal to 0 simultaneously. Anyone can be equal to 0. If you think a little bit deeper, you will understand it. Thank you. So finally, the standard form of a linear equation in two variables is ax plus by plus c is equal to 0, where a, b, c are real numbers and a square plus b square is not equal to 0. These are the conditions and this is the standard form. Now what if we have a pair of equations, because the chapter itself says it's pair of linear equations. So you have one equation like this, ax plus by plus c is equal to 0. Then another is also a linear equation in two variables, so that also will be in the same form. Then how to differentiate between that and this one? Let us see. What actually makes the difference? 0 does not make difference. And c can change. Y is y, x is x. So what all can change here? Only the coefficients. So coefficients change and only then we say the equations are different. So let us name them like 1 for all the coefficients of equation 1 and 2 for all the coefficients of equation 2. So if we have two equations, the linear equations in two variables, the first one will be considered a1x plus b1y plus c1 is equal to 0, and the second one will be considered a2x plus b2y plus c2 is equal to 0. When I say a1, you should understand that this is the coefficient of x of the first equation. When I say c2, you should understand that this is the constant of second equation. Right? Thank you. Now the second question says, how many solutions does x minus 4y is equal to 5 have? Now let us first of all think, is it a linear equation in two variables? We have two variables x and y and their powers are 1 and another constant, its variable power is 0. Therefore, it's of degree 1, hence we call it a linear equation. And it has two variables, therefore we say linear equation in two variables. And there is an equality symbol, so we call it a linear equation in two variables. But is it in the standard form? The standard form is supposed to have something like this: 1x, very good, 4y, yes, and some constant, but the constant is on the RHS of equality. Then what can you do? Get it back so that it becomes minus 5 and equal to 0. So this is the standard form. No matter whether you write in this way or this way, does not matter, but this is only the standard form. But it doesn't mean you're wrong in writing. So this is only the standard form. Now, the question is not about its form. The question is about how many solutions it has. So to say how many solutions it has, you should know what a solution is first. What is a solution? For example, if I say 2x is equal to 12, what is the solution for this equation? What can be the solution here? You have 2, it is always 2 wherever you go. It is 12 wherever you go. Then what is the thing you have to decide and you can decide? It is the variable that will decide. So in place of the variable, if you put some value, this equation becomes valid. This becomes satisfied. This becomes LHS is equal to RHS. So that value of x, the variable for which this equation becomes valid, satisfied, LHS is equal to RHS, then we call that value as the solution for this equation. So let us see, can every number and any number be a solution for this? Put 1 here, 2 into 1 is equal to 12. 2 ones are 2 is equal to 12. Does 2 become equal to 12? No. So 1 does not satisfy this. So 1 is not a solution to this equation. Let us take 2. 2 to the 4 is equal to 12. Does 4 become equal to 12? No. So 4 also doesn't satisfy this equation. Therefore 4 is not a solution to this. Then take 6. 2 sixes, 12 is equal to 12. Yes, this satisfies the equation. The equation becomes valid for the value of x, which is for the value of x equal to 6. So 6 satisfies this equation. Therefore x is equal to 6 is the solution for this equation. So no matter what number you take that does not satisfy this equation, only 6, that means only one value 6 can satisfy this equation. That means we can say this has only one solution. So a linear equation in one variable will have only one solution. Then linear equation in two variables, can we guess, does it have two solutions? Let us see. Now let us take 1 in place of x. So we'll take it as 1 into 1 minus 4y minus 5 is equal to 0. Then this becomes 1 minus 4y minus 5 is equal to 0. So minus 4 will be like this only. So this plus 1 and minus 5, that becomes minus 4 is equal to 0. So minus 4y is equal to 4. Y is equal to 4 by minus 4. That implies minus 1. So when x is equal to 1, y must be equal to minus 1. Then this pair is a solution to this equation. So when x is equal to 1, y becomes minus 1. So shall we think this is the only solution, or do we have one more solution? Let us see. If you take x is equal to 2, what happens? Let us see. So 1 into 2 minus 4y minus 5 is equal to 0. Now this becomes 2 minus 4y minus 5 is equal to 0. So minus 4y, this becomes minus 3 is equal to 0. So minus 4y is equal to 3. Y is equal to 3 by 4 minus. That means this becomes minus 3 by 4. So when x is equal to 2, y becomes minus 3 by 4. This is also a solution for the given equation. So this is one solution, this is one solution. You may think, sir, why it can have two solutions? Because the value of y depends on what you take for x. If you go on changing the value of x, the value of y also changes in order to balance it. It is like the balance. If you go on changing some weight on one side, in one plate of the balance, this always fluctuates until you get equality. You should keep on changing this value also. If you remove some weight, you have to remove some material. If you add some weight, you have to add some material. So material or the content in this plate varies accordingly as per the weight in this plate. Like that, the x and y, in order to make the balance, in order to maintain the balance, they change their value accordingly. As x changes, y also changes. That means if you keep on changing the values of x for 100 times, the value of y also changes 100 times. That means we can say this has infinitely many number of solutions. That means it has infinitely many solutions. A simple way to understand and remember is this represents a linear equation. And what is a linear equation? If you draw it on a graph, it represents a straight line. And what is a graph? If this is the graph of this equation, every point on this graph satisfies this equation. And every point that satisfies this equation also lies on the same line. From this we can understand it like this in an easy way. Because this is a line like a linear one, it is just like saying my house is on this way straight. So where can my house be? Can it be here just beside my street? Can it be here just behind the village? Can it be here just behind the mandal? Or where? It can be anywhere on this line, even beyond this country. So there are infinitely many number of possibilities for that. So all the possibilities are considered the solutions for the given one. That means a linear equation in two variables has infinitely many solutions because of presence of two variables. This is the main thing you should understand. Now coming to the third question, write all the possible situations that arise when a pair of linear equations in two variables is plotted on a graph. For example, you have a graph, and if you draw the graphs for a pair of linear equations, that means there will be two equations for which you have to draw the graphs on the same sheet. And because this is a linear equation and this is also a linear equations, you will end up in getting two lines on the same graph. Two lines on the, so this may be one line and this may be another line. Like this, you will have two lines on the graph. So he is asking the possibility of situations how the two lines can be aligned, arranged, or exist on the graph. How, in the sense, do they lie one inside the other, or do they lie apart from each other, parallel to each other, or do they simply intersect once? This is what he is asking. Simple. For everything there are some possibilities. That some things have limited possibilities and some things have unlimited possibilities. Now if you draw a graph for this one, let us see what can be the graph. So let this be x-axis and let this be y-axis. So now if you draw a graph for this, let it be some line. Yes or no? This is equation number 1. Now what if you draw the graph for the second equation in the same sheet? So if you draw the graph for the second equation in the same sheet, that graph may be along the same line. This is one chance. Yes or no? Can there be a chance? Definitely. Why not? That can be inside the same line. That means both lines coinciding with each other. So in that case the graphs coincide. In the second case, instead of coinciding, it may stay a little bit away but along the same line parallelly. This is second case. Here every point on this line is also the point on that line. So both have infinitely many common points. But when it moves away, it follows this line along the same line but never touches it at any point. So the number of common points is 0. So this may be one case where the lines are parallel and they do not touch each other at even a single point. And there may be also another case wherein instead of being parallel, it will be a non-parallel line. So what is a non-parallel line? It touches the line at one point. It never touches the line at more than one point. So touching the other graph at one point, or touching the graph at no point, or touching the graph at every point. This is the wonderful expression we can give. If two lines are there on the same graph, they will have either all points common to each of them. So one lies inside the other, or no points common in between them. They never touch each other, or one point lying common to both of them. It's all the matter of how many points that are common in between these lines. In the first case, every point is common. All the points are common. The maximum number of points are in common. Infinitely many number of points are in common when they are coinciding. In the second case, when they are parallel, no point is lying common. They have no common point. That means there are 0 common points between these two graphs. In the third case, when they are touching each other, that is, they are forming the intersecting lines, there is only one and only one common point between these two lines. So every point being common, no point being common, one point being common. These are the three cases that arise. Now, is there any possibility for 2 points to be common? You see, just if you draw a line and draw another line, it goes on extending but never turns back to make another intersection. So there is only possibility for one common point when they are not parallel. So these are all the three cases that arise when you draw the graphs for the linear pair of equations. And our great mathematicians have done the most wonderful job that they will be able to tell us the nature of the graphs of these equations even without drawing the graph. They can simply say whether they touch at one point or they whether never touch each other or they lie one side each other. They can simply say how wonderful it is. Yes, that is why mathematicians are great and the students doing maths are really great and they are tomorrow's scientists. So let us see how they can say that. It's all decided by the coefficients. Let us see how it happens. Simple. Take a1 by a2, b1 by b2 and c1 by c2. That means the coefficient of first equation by the coefficient of second equation every time. Of that of x, that of y, that of the constant. Keep on taking. That is a1 by a2, b1 by b2, c1 by c2. Now if you take these and you will have some values, depending on their values you can decide how the nature of the graphs can be. So let's take the first case where all of them are equal. Is it possible? Yes, there is possibility. Why not? There can be possibility and we'll definitely come across such kind of problems in this chapter. So when all are same, simple to remember, wherever you go I follow you. So wherever you go I follow you, because if this is followed by this, this is followed by this. So wherever it goes, this line follows that. So we can simply say when a1 by a2 is equal to b1 by b2 and that is equal to c1 by c2, we say the graphs will be coinciding lines. That means there are infinitely many common points. And you know what? The common points are nothing but the solutions. So there are infinitely many solutions for this. Yes, every point is a solution. Whatever you say, that is my opinion. Whatever you don't say, that is not my opinion. Whatever you say tomorrow, that is my opinion tomorrow. Whatever you say the day after tomorrow, that will be my opinion the day after tomorrow. So every point is a solution. Wonderful life. So in this case, when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, the lines are coinciding lines and there are infinitely many solutions. And this pair of equations are called consistent pair. Consistent pair. Why? They have some solution. If there is no solution, we say inconsistent, not stable, not giving proper solution. That is inconsistent. Because they are giving infinitely many number of solutions, we call it a consistent equation. Now let us take the second case where you take the same like this. Now let us make a change. Instead of all being same, let us make this not equal to. What happens? So it was yes there and no here. So they get separated. You said yes there and no here? No, let us get separated. So they never meet. That means they will be parallel lines. So this kind of things, when they happen, their graphs will be two parallel lines with no single common point. That means there will be no solution for them at all. So we can call them inconsistent because this is equal here and not equal here. They are not consistent. So we say they are inconsistent pair of equations. They have no solutions. Therefore, they are parallel lines on the graph. Now, what if this is also not equal to 0? So let us forget about this one. Let this be not equal to 0. Now, the is equal to shifted to inequality and this inequality shifted to this place now. Let this be equal to or does not equal to, does not matter at all. So this all matters first. So if this is not equal to 0, what happens? You started no at the beginning itself. So they will be cutting each other. So they will be intersecting lines with one solution. That means if a1 by a2 is not equal to b1 by b2, the graphs will be intersecting lines. There will be only one solution. So we can say they are consistent pair of linear equations. And based on these criteria, all this chapter runs. And that is how we learn it very interestingly. Thank you.